Today in lab, you will be performing the Proctor test for soil compaction. This lab is covered by ASTM standard D698.
The purpose of today's lab is to use a standard proctor to replicate field compaction in order to determine the optimum moisture content for soil compaction. This is done by finding the wet unit weight, gamma T, of a certain water content in the soil sample, using it to then find the dry unit weight, gamma D, and creating an optimal water content curve with the results. For today's lab, you will need a large bowl, a proctor hammer, a scoring knife or cutting tool, a 4-inch proctor mold with collar, soil spoon, an electric scale, a 1000 milliliter beaker, a squeeze bottle, 3 oven-safe tins and a permanent marker, a large tray, and the soil sample.
For the procedure, you'll start by zeroing your large bowl on the scale and obtaining roughly 2,000 grams of the soil sample. It's okay if you're not as skilled as us and your measurement isn't exactly 2,000 grams, but be sure to record your sample weight for the following steps.
In lab, your TA will give your table a specific water content. Using 1 gram per milliliter, you can calculate the necessary amount of water to add into your soil sample to achieve this water content. Measure the water into your 1000 milliliter beaker, and then use the squeeze bottle to slowly add the water while mixing into the soil sample until the moisture is evenly distributed. While mixing, be sure to check the bottom and edges of the bowl for dry soil. Also, occasionally scrape the soil off your spoon and mix into the sample.
To begin the soil compaction, make sure the proctor mold and collar are attached securely. You will want to place the proctor mold into the tray and set it on the ground before beginning this step.
You will then begin to fill the proctor mold with the moist soil sample until it is about halfway up the base, very lightly compacting the soil in the mold with a seeding hammer as you fill it. Make sure to not use excessive force as this may skew your results.
Once you have placed the first layer of soil, you will need to use the proctor hammer to compact the soil. In order to do this, you will place the base of the hammer on the surface of the soil and raise and drop the hammer 25 times, rotating in a circular pattern around the mold.
After 25 drops, use the cutting tool to remove any residual soil clinging to the sides of the mold, as well as scrape the top of the soil sample to allow a strong bond with the next layer of soil.
We'll repeat this entire process twice more, filling the next layer to roughly 2/3 of the way to the top of the collar, and for the final compaction, filling to 3/4 of the way to the top of the collar. Whew, one more to go.
After the final soil compaction is complete, remove the collar from the mold and cut any excess soil that is above the base of the mold, as you want exactly 1/30th of a cubic foot sample.
Once the excess soil is trimmed off the proctor mold, have your TA assist you with using the extracting device to remove your compacted soil from the base of the mold. This step is very satisfying with a lower end water content and a bit trickier with a higher one.
Once extracted, you will need to record the exact weight of your block of soil. Next, you will need to make 3 score marks on the side of the sample, indicating where the soil will be cut, creating 4 equal-sized pieces.
Before completing this next step, remember to record the empty mass of your 3 labeled soil tins.
After cutting the sample where scored, collect at least 50 grams of soil sample from either side on the inside of each chunk and place into one of the 3 labeled tins, collecting a portion of the whole from along each of the 3 cuts.
You will then record the mass of the 3 filled tins in grams before popping them in the oven to dry for 24 hours.
Be sure to clean up your lab station and equipment before leaving for the day.
You will need to come back the following day to record the dry weight of your 3 soil tins to be used in your calculations. Here's an example chart for the calculations you will complete after lab. Once you make your chart, the conversion factor K is from grams to pounds. The volume of the mold is 1/30th of a cubic foot. To calculate the moist unit weight, it is the mass of the moist specimen in grams times the conversion factor K divided by the volume of the mold. Dry unit weight is found by the formula listed on the screen from the ASTM standard.
Using the results from the chart on the previous slide, you will construct an optimal water content curve shown here in blue, with an accompanying zero air void curve shown here in orange.
Good luck in lab!
And always beware of poorly compacted soils.